Hi guys, it's Katia Chavez and I work at the Natural and Social Science Lab at Miami-Dade College, Kendall campus. We're going to review two basic concepts this time, just Mol and Avogadro's number, specifically in the application in a given formula, chemical formula, okay? Let's look at this molecule here. It's nitric acid. In one molecule of nitric acid, I have hydrogen, nitrogen, and oxygen atoms, right? But remember that the subscript tells us how many atoms of each we have. So in the case of hydrogen, I have no subscript. No subscript means 1. So I have 1 hydrogen atom. What about nitrogen? No subscript again. That means I have 1 nitrogen atom. And for oxygen, I have 3 as a subscript, so I have 3 oxygen atoms. Now, what happens when I don't have 1 molecule, but maybe 2 molecules of nitric acid? I have to remember this, that this number 2 is going to get multiplied by each of these subscripts. So, let's take as an example hydrogen. Hydrogen has no subscript, right? It's 1. So, I'm multiplying 1 times 2. That gives me 2. So, I have 2 atoms of hydrogen. What about nitrogen? Nitrogen has a subscript of 1 that has to get multiplied by 2. 1 times 2 means that I have 2 atoms of nitrogen. What about oxygen? Oxygen is 3. I have to multiply 3 times 2, which is 6. So I have 6 atoms of oxygen. You see the difference here? Each time I change the number of molecules, I have to multiply that number by each of these subscripts. And every time I talk about 1 molecule, I'm going to talk about atoms. Now let's see what happens when we talk about moles. So I have nitric acid again, correct? And now I'm going to say that I have 1 mole of nitric acid. In 1 mole of nitric acid, I'm going to have, remember that the subscript for hydrogen is 1, so 1 times 1 mole is 1 mole of hydrogen atoms. Now let's go with nitrogen. Nitrogen is 1 times 1 mole is going to give me 1 mole of nitrogen atoms. Oxygen is 3. 3 times 1 mole is going to be 3 mole of oxygen atoms. This is very important so that you can see the difference between talking about mole and talking about molecules. When I talk about moles, my answer is going to be also in the mole form. So if I have 1 mole of nitric acid, I have 1 mole of hydrogen atoms, which means, remember that 1 mole is 6.02 times 10 to the 23? So it's going to be 6.02 times 10 to the 23 hydrogen atoms. If I have 1 mole of nitrogen atoms, 1 mole is equal to 6.02 times 10 to the 23 nitrogen atoms. Now we have 3. This is going to be a little bit more complicated because I need to multiply 3 times 6.02 times 10 to the 23. And this if you do it in your calculator and you put it in your scientific notation, it would be 1.8 times 10 to the 24th oxygen atoms. So see how the big difference between the final number of atoms here and here. Here we talked about 3 atoms only, and here we're talking about 3 mole, which is 1.8 times 10 to the 24th number of oxygen atoms. So you have to be careful with the units that you're working with. If you refer to one molecule, you're talking about atoms. If you talk about mole of molecules, then you'll be talking about mole of atoms. In other words, a big number in the order of 10 to the 23. Okay? So stay tuned, and you're ready now to practice more problems involving Mol and Avogadro's number. Stay tuned.